spiders on drugs. Orb weavers are well known for their iconic webs. You have almost certainly seen them before. What you might not know is that many orb weavers remake their webs regularly, eating their webs and all of its associated debris, functionally recycling them, and spinning new webs for the new day. Starting with a new scaffold, anchorings, radial spokes fanning outwards from a central hub, and then the spider lays a temporary spiral as a guide, and finally replaces that guide with the sticky capture spiral that will do the actual catching. In under an hour, orb weavers remake a web of geometric regularity. The orb weaver web is a complex animal behavior that leaves behind a permanent, measurable record of the mind that produced it. If someone, say a mad scientist, were to disturb the spider's nervous system while it builds, let's say with huge amounts of hallucinogenic drugs, the disturbance is written into the silk web. In the 1940s, a zoologist named H.M. Peters was trying to film spiders building their webs. But spiders like to build webs at 2 a.m., which is obviously annoying. Peters wanted his spiders to build at a more civilized hour, and he wondered whether he could force them to with a little chemical persuasion. So he made a request to a pharmacologist named Peter Witt for a drug to shift the timing of web construction. Witt provided lots of drugs: cannabis, mescaline, morphine, scopolamine, benzodrine, which were given to the spiders, and they waited to see whether they would shift their working hours. They didn't. But something else happened. The drugs changed the shape of the web. Some webs were smaller, some with uneven radii, some with the capture spirals gone, irregular, or the whole web collapsing. Witt measured everything: the number and regularity of the radii, the spacing and evenness of the spiral, the total area covered, and the number of completed cells. Video of the construction process itself allowed him to see not just the finished product, but the sequence of building movements that produced it, and to identify at which stage a drug interfered. So what did the drugs actually do? Spiders on amphetamines produced irregular spacing of both radii and spirals. The individual building movements, the probing leg motions by which the spider measures and places each thread, remained normal. The disorder was, in the large scale, one of geometry, not in the actual motor control. The severity of the distortion tracked the dose. The spider was still making precise movements. It had simply lost its higher order sense of where to put those movements. Barbiturates could interrupt a spider mid-task, causing it to abandon the radius building stage before completion. The spiders began the structure and simply stopped, the web left in fragments. Scopolamine produced disorientation. A spider under the effects of scopolamine would lose its sense of direction so thoroughly that a single web might contain multiple partial spirals winding around several centers, as though several incomplete webs had been attempted at the same time. Chlorpromazine, diazepam, and psilocybin would prevent web building entirely. LSD did something the other substances didn't. It increased the regularity of the web. The spiders built webs of larger than normal size, with more evenly ordered elements than the controls. This is one of the most counterintuitive findings. LSD, a drug famous for inducing sensory chaos and hallucinations, produced a greater geometric order in the spiders. The one drug that produces the most startling reactions is caffeine. By the reckoning of a typical coffee-addled grad student, caffeine is the mildest of stimulants. Yet in the web assays, caffeine is a bomb. Spiders dosed with caffeine produce some of the most disorganized webs of any compound tested, structures so degraded that they barely qualify as webs. The reason for this is in the origin and purpose of caffeine. Caffeine is a plant chemical defense, specifically against insects. Measured by lethal dose in a small animal, caffeine is considerably more toxic than other drugs, like cannabis. The amount of cannabis's active compound required to endanger a small mammal is extremely large, while caffeine reaches a comparable danger at a far smaller dose relative to body weight. The whole reason we find caffeine in coffee, tea, and cocoa is that those plant lineages independently evolved the compound as an insecticide. It is meant to be a chemical weapon. What humans have done is domesticate that weapon, brewing the plant's chemical defense into a morning habit and scaling ourselves large enough that a dose which would devastate a spider merely stimulates us. The exact mechanism for how these drugs interrupt web building is only partially understood and overall tedious to talk about. This isn't a chemistry channel. The short version is some of these drugs interrupt the control of silk synthesis, either making it too fast or too slow. So even if the spider's judgment is left intact and it goes through its normal behaviors, the web will be deranged. That is on top of any mind-altering effects the drugs might have. In 2004, drugged spiders were revisited, but this time with more modern techniques. Unfortunately, in this more recent study, fewer drugs were looked at. Scopolamine showed no effects at low dosage, and at higher dose, it reduced the frequency at which spiders build webs at all. Amphetamine and caffeine produced significant changes in both the frequency of building and the geometry of the finished webs, confirming what was already known. These drug web experiments dispelled an old assumption that web spinning was a purely innate, fixed behavior, executed identically every time regardless of the spider's internal state. The drug webs demonstrated that this precise, seemingly innate behavior was in fact vulnerable and sensitive to the chemistry of the nervous system. When a spider, under the effects of amphetamine, spaces its web radii unevenly, we are watching a nervous system fail to organize a basic task. And even that mechanism remains only partially understood. A full account of exactly how each class of drugs act on the specific neural circuits that translates a spider's sense of space into precise movements that builds a web does not yet exist. The finished web is downstream of a great deal of behavior that remains dark to us.